Thank you. Thank you very much, Christina. Okay, let me start my talk now. Hello, everyone. Good morning, good afternoon, and good evening. How are you all doing? I'm so glad today to be here and present to you my topic, the test optimization through the risk-based validation approach. I'm Felix from Malaysia, and my co-author Jim Pei and myself worked together and came up with this interesting topic. These are some little info about myself. I'm a software quality engineer from Intel, focused on the software product quality and process improvement. And previously, I worked in Motorola Solutions and was mainly involved in software testing, software product quality, supplier engagement, and business process improvement. I'm a certified DSS Green Badge from Motorola Solutions since 2019, and also a degree holder in the computer science from the University of Bolton in the UK. These are the agenda for today. So today's topic will cover the below. I'll briefly talk about the software testing and the test constraint, and the test technique selection, where I'll provide some guidance on which validation approach is best suited for an organization. For the software validation transformation, I will address the area of transformation, including the risk analysis, defect prediction model, project monitoring and control plan, and building up the subject matter expertise. I'll also provide you some examples of the source of impact analysis. For the risk management, I will talk about the various ways of managing the product risk. And the validation task traceability is about mapping between the validation task and the original impact analysis summary. The gap analysis and maintenance is to review the typical misses during the impact analysis. I will also provide you a sample implementation result of the risk-based validation approach. And finally, we will look at future work and area to research. So what is software testing? I quote this from ISTQB. So it mentioned that the software testing is a way to assess the quality of the software and to reduce the risk of the software failure in operation. So as you all are already aware that the purpose of the software testing is to ensure that the developed software meet the defined requirements and help in finding the defects, ultimately leading to improved customer experience. So I understand that when coming into testing context, there are plenty of the test constraints we can consider. However, in this topic, I'm only focusing on the two main test constraints, which are the resource and the time constraint. So the test constraint actually prevent us to achieve the efficient and the effective testing. So for the resource constraint, often the project teams have to deal with the unplanned activities, which take away time from the planned activities or add the additional scope to validation. And for the time constraint, often the repeating the regression testing, even for small changes, could cause the release delay. So now that you have seen the constraint, how do we deal with selecting the right testing techniques while dealing with these constraints? Right testing technique has to satisfy the testing goal and fulfill the risk analysis. So from the example in the diagram, to achieve the effective testing, we should test everything to obtain the full test coverage so that we can find as many defects as possible. And to be efficient testing, we should minimize the testing time or the resources and only perform the certain tests, but we may not find as many defects as possible. So both scenarios with the existing test constraint will prevent us from satisfying the testing goal. Next thing to consider is the risk analysis. the team can create a high-level fundamental view on the risk analysis. They can define the testing goal or the scope they want to achieve so that they can evaluate the possible risks by asking the list of relevant questions. So this diagram shows the sample question like which of the impacted areas of the defect fixes, or what is the critical levels, the impacted area. So from this question, you can come up with selecting a right testing technique to fulfill your testing. So in this example, the risk-based validation approach is the best selection. Anyway, the organization may adopt different test techniques throughout the product lifecycle, as there are different needs and risks in each milestone. So now that we have established the risk-based validation approach is the best technique. So what is actually the risk-based validation? The RVV. So it is one of the approach within the validation strategy. The RVV is all about the summary of the software code changes and the relevant impacts. So below is the high-level overviews of the RVV and its flow. So first, the input from the software development team, which could be the new features, the bug fixes, or anything causing the code change. The development team will document all these details of the code changes. Then these impacts are shared with the validation team during the project meeting. The test analyst will pick up and perform the impact assessment to determine the validation scope for the milestone. I'll talk more about the impact assessment later. So since there are so many validation tasks created in each milestone, so the task prioritization is necessary. And test analysts can further enhance the RVV with the defect prediction model. The defect prediction outcome may provide more insights from the defect prediction perspective. Now let's go deeper into the RVV objectives. First, the analysis of the impact-based risk assessment is critical to the success of the project commitment and minimizing the escape defect to the fields. In reality, we can't totally avoid the escape defect from project, but what we can do is to minimize them. However, the end goal for the testing is to meet the project commitment and to make sure that the project is delivered on time with the high quality standard. And second, achieve a project outcome that balance the risk with the quality, feature, budget, and schedule for the time, resources, and effort that have been invested in a program. The RVV mainly focus on performing the right testing, but not all the testing because of the test constraint. It also focuses on the specific area of the product where there is a high impact on business due to failure or high likelihood of the failure in the production. And the early defect detection and allowing a team of the software developer to fix them as early as possible. And last but not least, the quality control is to improve on end-to-end customer experience. So now you all know about what is the RVV approach. I'll talk about the process transformation from the traditional validation to the RVV approach. Nowadays, the software validation world has rapidly changed. The process transformation is dependent on organization's current process maturity. Normally, it can be measured and represented through the CMMI levels. Organization with higher maturity level tends to focus on process improvement efforts and prioritize on manageable numbers of practice areas. So for the RVV approach adoption, the below 4 areas are taken into consideration. So they are the risk analysis, identify a defect prediction model, develop a monitoring and control plan, and building up the subject matter expert. Let's explore one by one. In software validation, risk analysis is the approach to identify and analyze risks, implement a control and mitigation plan, and measure how the risk may create threats to the functionality, stability, security, or performance of the application. These diagrams show the risk analysis flow at different phases of the product lifecycle. Risk identification refers to the activity a team can predict risks with association to the test condition. Example of the test condition can be the input and outputs or any actual outcome such as username and password. Team can evaluate the risk from this test condition. So once the risks have been identified, the risk assessment output will be documented with the recommended risk strategy in the test plan. The test analyst will conduct the risk assessment to ensure that all the open risks are addressed and implement the risk mitigation if there is. Priority of the risk can be adjusted according to the current situation. The risk assessment and the mitigation activities are corresponded to the test monitoring and control activities. They are continuous processes and will be monitored to identify for new risks. So once the testing done, the risk tracker will be updated to generate the risk report. Test metric can provide a high-level view whether the testing goal is met or not. The team can re-evaluate the open risk with reference to the test metric and predict the new risk. The risk analysis process will repeat until all the open risks are closed and there is no new risk observed. The risk report will be communicated to the project lead for action plan. This is to avoid factors that can bring negative impact to the project or the business. Okay, let's switch gear to the defect prediction. So the defect prediction, as the name implies, is the activity to predict the future defect arrival based on the historical defect dataset. So it shows the probability of the software errors that might have been invented by the development team. So it is also a benchmark to gauge the software performance by ensuring the defect arrival is consistently approaching the predicted number and provide the level of confidence and the quality assurance of the software application under development. Defect prediction outcome can help to adjust the RBB approach to improve the test coverage and also to reduce the risk. So just bear in mind that when you do the defect prediction, we must consider about the project size, project complexity, and any other external factor that might impact the defect prediction decision. The comparison must be apple-to-apple comparison. You cannot use the historical data, defect data, from a small project to make a prediction for the large-scale project. Okay, I'll move on to the monitoring and control plan. So every project must establish a monitoring and control plan. The intention is to ensure that all the software validation activity, such as the effort, the risk, the schedule, are reviewed at a regular cadence, which help to identify the problem when something went wrong. So for the resource evaluation is to ensure that the project resources, for example, creating the test cases or performing the test execution activity, are competent to complete the task on time. And for the buffer allocation, this is to check that the extra allocations of the time or the resources during the planning stage is still sufficient. Risk analysis on the action plan is to evaluate the current risk and mitigation plan and to track the new risks. And last but not least, the defect detection rate based on the actual versus the plan is to ensure that there is no unexpected outcome. If actual defect arrival is far below or above the prediction, the project team must reperform the analysis to identify the new trend. Alert will be promptly triggered for any unexpected outcomes that occur. Okay, this is the last area of the process transformation in this topic. The SME is anyone who is proficient in specific knowledge area and able to conduct the specific assignments on the software testing. Building the SME is a long-term plan to retain the competency. In general, the SME can be built based on their knowledge, their working experience, talents, research, study, their skill, and their ability requirements. So in a project, different SME are needed to perform the testing on the different features. However, a SME can have his or her expertise in more than one features. Sometimes the SME are required to make decision and judgment based on their skill set in situations such as the requirements are ambiguous, or to stop the testing if the software feature is unstable and so on. So to summarize the process transformation, the organization must consistently transform to achieve the long-term goal and benefit. Now let me provide you an overview. Where are all the impact analysis coming from? So the code change may happen due to the different reasons. Business need adjustment is quite common nowadays, and it happens from time to time. The business world is always challenging. Organizations must be more competitive to accelerate their business strategies. For example, the code refactoring activity. It is used for a better maintenance solution. The customer request. In fact, the customer can make any new request to the existing product or the new product, depends on their business need. Organizations must also constantly perform the analysis and improve their current product with the new requirements and the new technology to attract the new customer. And of course, the defect fixing. This is the most common code change activity throughout the product lifecycle and for the post-release. Software code change is unavoidable. It adds a new functionality, improve and enhance the existing capability in order to extend its lifespan, but it sometimes could result in failures. So impact analysis help to oversee the risk of the change and resources which we should plan forward for implementation of the change. As you all know, the RBB approach risk. So these are some of the way for better product risk assessment. Early commencement. Teams should start the RBB as early as possible to identify the correctness of the assessed impact or to determine if more validation should be performed. If there is anything goes wrong in the early phase, the team still have time to correct it. Test prioritization. So always prioritize the validation, mainly in the high impact areas. If time allows, then only validate those from the medium and the low impact areas. Mitigation and the contingency. Always ensure that the mitigation and the contingency plans are reviewed and updated just in case this is needed. This is very important and could cause the project fail. Measurement is to measure that on how well the RBB at finding and removing the critical defects. You may ask the question, are all the risks associated in the critical defects finding and removing have been addressed and closed? And what are those open and new? Continuous risk assessment. Risk assessment should not just stop at the impacted area. The team should proactively repeat the risk analysis on the non-impacted area to minimize any misses. So in most cases, a mission critical project tends to take the lesser risk as compared to a normal project. Okay, we all know that each testing type has its own strategy. With no exception, the RBB has its own strategy as well. So now let me briefly explain to you what is the RBB strategy. So the RBB strategy aligns the validation activities with the business priority and achieve the optimal risk coverage with the focused validation. So from this chart, it can rapidly reach over 80% of the business risk coverage, using only 20% of your test effort covering on the high-risk test cases. So when the releases going on, they continue to cover the medium and the low-risk test cases. With the RBB approach, the risk coverage optimization shift the focus from the test coverage to the risk coverage. So we just learned about the RBB strategy. This chart shows the ideal defect arrival trend when we optimize the risk coverage with the focused validation. The defect detection rate has a sharp increase at the beginnings of the project and decrease over time. At the beginning, the validation focused on the high-risk impacted area to flush out most high-impact defects. So once completed validating all the high-risk test cases, the defect arrival trend is flattened, which is not worth to continue the validation. In RBV, so we know that the impact is the input, risk analysis is the process, and so the output is the validation task. Tracking the validation task must be precise to ensure that the integrity of the overall process. The validation task can be easily traced back to the impact analysis table because each task is tied to the unique defect ID and the priority. So with reference to the defect tracking tools such as Jira, Bugzilla, HPLM, Mantis, and so on, normally specific fields exist in the tools to capture the details of the impact, such as the feature list, the root cause analysis, the priority and the exposure, and so on. This can improve the accuracy, which ensure the original impact of the specific defect is identical in the IA table. And for the completeness, where the test analyst can read the defect details to have a better understanding of the actual issue. Okay, this is a sample impact analysis table filled out by the software development team. As you can see that the same feature lists are plotted in both the horizontal and the vertical axis. The purpose is to capture the impact that potentially happen on either a single feature or a multiple feature that have code changes. Impact with the dedicated priority are filled out in the relevant cells to indicate that the potential impacted area. This impact analysis table will be shared with the validation team prior to each validation cycle. The test analysts play an important role to interpret these impacts into the validation task creation. This is a table showing the sample validation tasks that created by the test analyst upon performing the impact analysis. The validation team can decide which tasks to be prioritized in such an easy way. These are the outcome of the impactful, the risk-based validation approach, which begin with the risk analysis, developing the control plan, and building up the subject matter expertise. Next, let me quickly brief you about the gap analysis and the maintenance for the RBB approach. So of course, interpreting the impact analysis requires the feature knowledge and the skill set. The test analysts normally lead the impact analysis work with the help from the different SME. However, during this process, there could still be some misses. This may be due to the lack of the quality review or any other reasons. These are the common misses that may occur, such as the incorrect entries, in the impact analysis table, misalignment between the defect prediction and the defect arrival, inaccurate risk assessment, ambiguous or wrong definitions of the validation, improper test prioritization, duplicate the entry of the validation task, and insufficient or redundant the test coverage. So these are those gaps that may observe. So we know possible misses may happen. So team must have an improvement plan to minimize or to avoid the misses. So these are the 3 steps for implementing the improvement action. First, turn the findings into the action plan. Then develop the plan to address the gap. And finally, assign and track the action plan. Anyway, the organization should implement the effective quality management system that provide the tools and methodology with the aim to maintain the risk-based validation as one of the most competitive approach to meet the organization's need, utilizing all the possible best practices to leverage the risk, the qualities, and all other resources. Now let me share with you the implementation results based on the past measurement conducted between the traditional full regression testing and the RBB approach. So as you can see that with the RBB approach, the test efficiency has been improved by about 50% with the same test coverage. And the test cycle time was reduced by about 30%. This is because the testing is focused mainly on the high-risk area, where lesser time required to complete the testing due to the validation scope is narrowed down. And there is no repetition testing, which the team can concentrate on the code change area rather than validate the whole test suite. However, the risk has been increased by about 20%, as this is the nature of the RBB approach. The 20% is the average numbers I got from the previous multiple projects that have been implemented with this RBB approach. Now let me conclude on this topic. As compared to the full regression test, the RBB approach adopts a more efficient way of doing the testing, as it is mainly based on the risk assessment. The RBB approach optimizes the risk coverage with the specific focus on the risk analysis, task prioritization, defect prediction, trend, and the decision making. It also has a proper risk tracking in the entire software product lifecycle. And the most important for organization is the return of investment, where the time and the resource are wisely spent. The ultimate goal is to achieve a project outcome that balance the risk with quality, features, budget, schedule for the time, resources, and effort that have been invested in a program. These are some key takeaways. So throughout this presentation, we have learned the following: the importance of the RBB approach to overcome the time and the resource constraint, the process transformation from the conventional full regression test to the RBB approach. And we understand that how the RBB approach aligns the validation activities with business priority. Understand how the functional area of the code change may impact the validation strategy. Understand how to manage the product risk level with the RBB approach. Test prioritization based on the impact analysis. Enhance the risk-based validation approach with the defect prediction model. And last but not least is the gap analysis for future process improvement. So with this, I'm ending my presentation for this topic. I would like to take this opportunity to thank my co-author Chin-Pei, my manager Vijaya, and the leadership for the kind support. Yeah, please let me know if you have any question.
Thanks, Felix. That was very enlightening, and you gave a lot of ideas on how we can approach, test optimization with RBB. So now it's open to the audience. Do you have any questions? Please put that in the chat, and then Felix will feel free to answer your questions. While we wait for questions, Felix, I just have one question. So you did mention saying there is, like, due to the the behavior of this approach, there is a 20% increase in risk. Have you ever kind of encountered a circumstance where there was something is there some sort of cons based on this approach, like that we need to be a little aware of while we take this approach? Any minor things that we can keep in mind to be mindful of?
Yeah, this is a great question, Christina. Yeah, so the risk, the 20% risk is actually the average number from the multiple projects that have been implemented with the RBB approach. And then, so when we implementing the RBB approach, we must consider whether this project is critical or not. So when the project is considered critical, so you should mix between the RBB approach and the regression testing in a project, because normally in a project it won't just release after the one cycle of testing. It could be the multiple cycle of the testing. So for the previous few round of the testing, so you can adopt the risk-based validation approach to actually focus on the risk on the affected area after you assess the risk. And then for the final round, you can expand your test coverage by performing the full regression test to ensure that you have achieved the 100% test coverage. This will actually minimize the risk of the 20%.
Right, makes sense. So should we also, like when we go into story level testing, in terms of feature level testing, is it better to take the RBV approach over the regression? It feels that way to be.
Yeah, I think RBB, in my opinion, actually is very suitable for the agile style testing, because during the agile development methodology, so when the feature develop piece by piece, so the risk can be assessed in a smaller area that you can focus on what you want to test on the feature instead of the whole feature completeness. So answering to your question, I think that this is the RBB is very suitable for the feature level testing at the beginning. But I think at the end, when the full feature is completed, you still need to go through the full regression testing to ensure that you have achieved the 100% test coverage.
Right. Cool. So we have a question from Rachel. Do you have any tips for testers to start doing more RBV if we need to convince upper management that this is a good approach? Are there any good ways to start small and try it out?
Yeah, this is a great question. Actually, I would say that the tips is in terms of the budget and the resources and the time used to do this, to perform this RBB, actually, if you compare to full regression testing, actually, there is how to say this, the way it is invested for doing the risk-based testing is actually relatively small. So you just need to start up with with the RBB, with just maybe just a few resources. And when you, for example, you want to do the full regression testing, you need 2 months time. So for the RBB, you just need maybe 3 weeks time. So you can come up with a plan. So the tip is you can come up with a plan as a comparison between the RBB and the full regression testing.
Cool. I hope
Yeah, is this
that
answering your?
answers.
Yeah.
Yeah. Right. Any more questions? I think we have like almost 2 minutes. Let's have more questions, guys, girls. Okay, I'll just give you guys 1 more minute. Let's see if there's more questions coming. But meanwhile, if there's like, anything like Felix that you could like, shed some light that might not have been discussed, that like, based on personal like experience in some project, how RBB was really helped you out. Maybe we can talk about that. Yes.
Sure. I think when you want to perform the RBB, the most important is the impact, because the impact is coming from the software development team. Okay. So the RBB is more about the impact and the risk. So when you want to do the testing, you need to know that what is the change. So the change is only implemented through the software development. Once the software development can provide you the tips of what area actually they perform the changes, then you focus on the area. You don't have to do the rest of the testing for the rest of the area, because they have not been any code change on the area. So don't spend time to go and do the testing on that non-impacted area. So what you need to focus is only on the code change area, those impacted area.